Alright, so today you should be starting on our next topic. So if you're a little ahead, then your date might be different than mine, but it should be on April 11th. And our topic, or our title today, is going to be evaluating functions. And this is topic B. And we are going to be on page 2 in my notebook. You might be on page 3. Make sure you take time to pause the video and add this to your table of contents. Alright, so today we're going to talk about evaluating functions. Okay, so let's talk about functions typically have two parts. So they have the input, and this is sometimes called the independent variable. And then they also have the output. And this is referred to as the dependent variable. Usually this is going to be x, and usually this will be y. Sometimes our output in function notation, it is the same thing as f of x, because it's the function of this x when you plug that in. So I want you to think of input versus output, and think of an ATM machine. So let's say we have an ATM machine. So here's our screen. So we're going to put in debit card. Okay, so this is kind of like our input. And we're going to get out cash. This is my output. Okay, there's only one amount. There's only one account for every debit card. So the input will determine what the output is. So now let's look at this as if we're doing a function. So let's say f of x, okay, remember this is read as f of x equals 2x plus 3. And we want to know what is f of 4. So see how that 4 is there instead of the x? That means that every time we see an x here, we're going to replace it with a 4. So this 2 right now is multiplying by this x. So when we replace it, we're going to put parentheses around it so we know we're multiplying. Then I just evaluate using my order of operations. 2 times 4 is 8. And this is still equal to f of 4. And 8 plus 3 is 11. So f of 4 equals 11. Now if we were going to connect that back to our coordinate plane, that would be 4, because that's our x value. And 11 is that's our output. So input, output. So if we were to graph that, we would go right 4 and up 11. We would be in that first quadrant. Okay, right 4, up 11 would be somewhere over here. We're in quadrant 1. Now let's look at a little bit more complex example. If we have f of x equals x squared minus 2x plus 6. Now I wanted to know f of negative 1. Process is going to be the same. I'm still going to be substituting this in for x every time I see it. But see how my x is negative right here? My input is negative. It's even more important to have parentheses around that because we need to include that negative wherever the x is. So if I do f of negative 1, I'm going to put negative 1 by itself instead of x, and then I'm going to put the 2 for the exponent on the outside. Minus 2 parentheses times negative 1 plus 6. Okay, now let's quickly remember what is negative 1 squared is negative 1 times negative 1. Two negatives make a positive, and 1 times 1 is 1. So this evaluates down to 1. Negative times a negative is positive. 2 times 1 is 2 plus 6. My next steps is just going to be to move left to right when I'm adding because I have all addition or subtraction. 1 plus 2 is 3. 3 plus 6 is 9. Again, my input is negative 1. My output is 9. So, f of negative 1 is 9. So if we were to write that as a point, my input goes first because it determines the output. And again, if I were to graph that, I have a negative x, but a positive y, so it's going to be going up here. I'm going to be in quadrant 2. Okay, so I want you to actually go ahead and try this one. And I want you to evaluate it at f of negative 3. And tell me what quadrant is it in. Is it in 1, 2, 3, or 4? You can show me after you've done it in class.